Today we're going to take a look at how to name acids and bases. We're going to start with bases because that's essentially a review of naming ionic compounds, because all of the bases that we're going to be naming are ionic compounds that just happen to have hydroxide as the anion. So if you remember, to name an ionic compound, you name the cation and then you name the anion. Well, again, for all of these, the anion is hydroxide. So we need to name the cation, which would be the metal or the polyatomic ion. Remember, the metal is just the name of the metal, and polyatomic ions are found in table E. So NaOH, Na is sodium, OH is hydroxide, so sodium hydroxide. MgOH2, Mg is magnesium, OH is hydroxide, so magnesium hydroxide. Remember, when you're naming ionic compounds, you're not identifying how many of each ion. That's determined by the charge of the ions and crisscrossing those charges. So we don't have to do anything special just because there happens to be a 2 for the hydroxide here. NH4OH. NH4 plus is the ammonium polyatomic ion. Again, that is on table E. And OH minus is hydroxide. So we have ammonium hydroxide. AlOH3. Al is aluminum. OH is hydroxide. So aluminum hydroxide. So naming bases, name the metal or the polyatomic ion, and stick a hydroxide at the end. With acids, it's a little bit more complicated because we need to identify really what's making up that acid. And there's kind of two different types. There's binary acids, which are hydrogen with just one other element. That doesn't necessarily mean that there's just two atoms in the binary, but there's only two elements for the binary. Or we could have acids that contain a polyatomic ion, which means there's more than one other element in that acid. So for binary acids, they start with hydro. You put in the root word of the other element that's there, and it ends in ic acid. So hydro, root word, ic acid. So HCl, hydrogen, one other element. So it's hydro, root word, ic acid. The other element is chlorine. The root of that would be chlor, so HCl is hydrochloric acid. H2S, again, hydrogen with one other element, hydro, root word, ic acid. So S is sulfur, so it's hydrosulf, ic acid or sulfuric acid. Sometimes people leave that UR on there. I know that that's putting the whole element in there and not just a root word. That's okay. I'm not going to be picky about did you get the wrong portion of the element name to get the root word. But you can let me know if you're having any questions on any of them. HF, hydro, root word. The root word of fluorine would be fluor. So hydrofluoric acid. HI, would be hydroiodic acid. So the iodine shortens to iodo. And H3P, hydrophosphoric acid. Again, it's the root word of that element name. Don't worry too much about exactly where that root word stops. Just do your best with it, and that's all you really need. Again, in terms of why there's two hydrogens with the sulfur and only one with the chlorine, that has to do with what charge the chlorine ion forms, which is -1. Hydrogen's +1, so it's one of each. With the sulfur, sulfur forms a -2 charge, hydrogen's +1, so there's 2 on the sulfur, or sorry, 2 hydrogens attached to that sulfur. Again, with the way we're naming acids, you don't do anything special stating how many hydrogens there are. That's based on what the charge of that other element would be. But it starts with hydro, root word, ic acid. Acids that contain polyatomic ions are going to be named a little bit differently. They are not going to start with hydro. And if you do accidentally start them with hydro, sometimes you're actually naming a different acid. So make sure if it has a polyatomic ion in it, do not start it with hydro. What you're going to do is you're going to look at the ending of that polyatomic ion name. If that polyatomic ion ends in -ate, you're going to change the ending to ic acid. If it ends in -ite, you're going to change it to us acid. So CO3 2- is the carbonate polyatomic ion. 8 turns to ic acid. So that is going to be as an acid, carbonic acid. Ditching the 8, changing it to ic acid. There's 2 hydrogens in this acid because the CO3 has a -2 charge. Hydrogen has a +1, so when I crisscross those charges, I get H2CO3. The ClO2- polyatomic ion is chlorite. Well, the ending of ite changes to us acid. So chlorite becomes chlorus acid when I put enough hydrogens to make it neutral. ClO3 is chlorate. Again, you're finding all the names of the polyatomic ions on table E. So chlorate, 8 changes to ic. So this would be chloric acid. Just as a note, if you accidentally started it with hydro, you'd have hydrochloric acid, which is HCl, not the HClO3. So be very careful. Sometimes if you're putting the hydro in it, not only is it wrong, but you'll be correctly identifying something different. Sulfite, ite changes to us. So this would be sulfus or sulfurous. Sometimes they put the UR back in. Again, don't worry too much about that. Just kind of follow the pattern that we're doing. So sulfus acid. SO4 is sulfate. 8 changes to ic. So that would be sulfic or sulfuric acid. Again, with the sulfur one, sometimes they put the UR back in. If you look on the table of common acids in your reference table, you will see it with the UR in there. And there's a couple other examples where they stick a couple extra letters in there, kind of just to make it sound better. Don't worry about that. If you're following this exact formula, you're fine. So again, look up the name of the polyatomic ion. If it ends in ate, change it to ic acid. If it ends in ite, change it to us acid. When you're trying to write the formula, look at the amount of the charge, and you need that many hydrogens in order to make it neutral. Again, if it was a binary acid, one that contains just hydrogen in that other element, you do the same thing with what charge that element forms, looking at the number of valence electrons or looking at the charge that it forms as an ion, and put in that many hydrogens to make it neutral. And when naming it, start it with hydro, put in the root word of the element, and end in